This is Babaiah, Assistant Professor of EC Department, MLR IT, Hyderabad. Previous lesson we discussed or we learned what are the block diagram representation, what are the basic elements are available in the block diagram, and what are the use of that every element, and also what are the block diagram reduction rules. Some of the rules, some 6 rules are we learned for the previous session, but today session we are going to learn remaining all block diagram reduction rules. Just here now we are going to use the block diagram reduction rules to reduce the block diagram, and finally we are going to calculate the transfer function of the block diagram. That is our aim. Now coming to the previously we learned the 6 rules, moving the summing point after the block, before the block, or moving the take up point after the block, before the block, as well as if the series blocks are available in the block diagram, just to combine the two single block, and also if any two or more than blocks are in the form of parallel, the two are also adding into the single block. All these are we learned for the previous session. Now today going to discuss the remaining all the rules. Coming to the 7th rule, just here the block diagram rule 7 block diagram reduction rules. In that rule 7 is interchanging the summing points, interchanging the summing point, just I am going to draw the two summing points. Just here observe, my input signal is A and one more signal is just here B signal, and another summing point I consider as here negative, end with negative the C signal. Here what is the output of first summing point? A plus B. Third summing point is A plus B minus C. This is our output. But now I am going to interchange these two summing points. These two summing points. Just here now I am going to redraw these two. These two are just interchange, means this one is moving to here and this one is the moving to here in place, just interchanging the summing point. Just here observe, this is my input signal. Now I am going to write this summing point, so negative sign C. Here output is A minus C, and apply to the second summing point, this one, second signal is B. What is the output here? A minus C plus B. Here A minus C is adding with the B, so here plus B. Same output, right? Here also same output, Y equals A plus B minus C. A plus B minus C, both are same. If we are changing or else we are interchanging the any two summing points, we will get the same output. So this rule also applicable to using the block diagram to reduce the block diagram and finally calculate the transfer function also. So that's why this rule also applicable, because of after the interchanging also same output, before interchanging the same output. So this rule also applicable to use in block diagram. Next, coming to the rule 8. combine the combine the combine the summing points, combine the summing points, combine the summing points. Just I'm going to write here these two summing points. I consider just A positive, and here the one more signal B, A plus B, and one more consider as summing point is C. Now two summing points are available. Here what is the output? A plus B. Here A plus B minus C. Here output. Right. Now I am going to combine these two summing points into the single summing point. Just I am going to draw like this. Input signal is A positive, and here B signal also positive, and here C signal also negative. Here C signal is negative symbol. So total output equals to what? Y equals to A plus B minus C. Same, right? These two are same outputs. Combine the two summing points. If any two or three, any summing points are available in block diagram, just we are going to combining that two summing points into the single summing point. Just two summing points consider as into the single. I am going to I arranged here two summing points into single summing point, right? Same output, A plus B minus C equals to Y. Same, A plus B minus C output. This rule also applicable because of before the summing points, two summing points are the same output. Then adding the or combine the two summing points into the single summing point also, we will get the same output. So this rule also applicable to use in the block diagram reduction rule. Next, coming to the rule 9. Rule 9. Splitting the summing point. Splitting the summing point. Splitting the summing point. Splitting the summing point. Now I am going to consider one summing point. One summing point. Positive. Positive A signal. And here C signal. And here B signal. B signal. This is the one summing point. Single summing point. Output is A plus B minus C. Now I am going to splitting this summing point. This summing point splitting into the two summing points. Just I am going to splitting like this. First summing point, A input signal and B input signal, A plus B. Next here, next summing point is just C input signal. Here A plus B, here A plus B minus C. So this is the output. Here observe, these two are same. Again these two are same, right? When we are having the any summing point is available with the more than two number of outputs, at that time if is applicable to splitting the summing point, applicable here, just splitting the summing that more than two inputs, single output. Two inputs, more than two means here three inputs are available for the summing point. That's why I am going to splitting it to the two inputs. Here A and B inputs to this summing point, and for this C is the input and A plus B is the input. Finally output is A plus B minus C. This is the way of splitting the summing points or else summing point. This is the way to split the one summing point into the two summing points, right? Next, coming to the rule 10, eliminate the eliminate the eliminate the negative feedback. For example, negative feedback loop. Eliminate the negative feedback loop. Just I consider here negative feedback. This is the input signal R of S, and here G of S is gain. Here output is the C of S. Negative feedback. Here end with the negative. This is the feedback gain H of S. Feedback gain, this one. Signal, same signal H of S, and here same signal C of S. Here C of S. So here what is the output? C of S into H of S. Here adding. So R of S minus here negative with C of S and H of S, right? Minus C of S into H of S. Here G of S is there. Now I am going to eliminate this negative feedback loop. Eliminate this negative feedback loop into the single block. Just I am going to, this is the input signal R of S. Output signal is C of S. Just here observe. The loop gain G of S divided by here end with the negatives are negative feedback. So right, I am going to consider 1 plus opposite. Here negative sign is there. So plus 1 plus multiply with these two gains G of S into H of S. Like this we are going to reduce the negative feedback loop. Just here for the calculation, here just observe. Here C of S equals to what? C of S equals to R of S minus C of S into H of S and G of S. Okay. Here I am going to split this one, R of S into G of S minus C of S into H of S into G of S, right? Here C of S is there. Now in this C of S term is here there and C of S is there. C of S plus, now this term is moving to the left side, C of S into H of S into G of S equals to R of S into G of S, right? G of S. What is the transfer function here? Transfer function is nothing but output. Output is C of S, right? Divided by input is R of S. Output by input, C of S, R of S. We need to calculate. Here C of S is output. Just to common this one. 1 plus G of S into H of S and equals to here R of S into G of S. R of S into G of S. Here transfer function we need to calculate C of S divided by R of S. This is the input signal, output signal. Finally we get the transfer function C of S by R of S equals to G of S is there. G of S divided by this term into the here G of S divided by 1 plus G of S into H of S. This is the transfer function. Here same G of S divided by 1 plus G of S. This is the transfer function representing in the block, right? Same. We get the same transfer function. Like this we are going to reduce the our available negative feedback loop. same as the 11th rule is just rule 11. Eliminate the positive feedback loop. Eliminate the positive feedback loop. Same process. Same applicable for the negative feedback loop. Here also same positive feedback loop. I am going to apply the input signal R of S to the summing point, and loop gain is G of S, and here output is C of S. The same signal output is here feedback gain. Through the feedback gain, I am going to apply this signal again into the input side with the positive, end with the positive, or else I am writing here positive. This is the positive feedback, but for the negative feedback here, just mention the sign is negative sign, H of S. Here same signal, C of S, H of S, same C of S into H of S, but here R of S is input plus C of S into H of S. Okay, now I am going to reduce this positive feedback into the single block R of S input signal, and here G of S is the loop gain divided by, here positive sign is there, so I am going to write the opposite, 1 minus these two blocks, multiply these two block values, G of S and H of S. G of S and H of S. This is the elimination of the positive feedback. Same process. Here just observe what is the output here, C of S. C of S equals to R of S plus C of S into H of S into this value, G of S. G of S. Just here C of S equals to R of S into G of S. Expand this one, C of S into H of S into G of S. Here same, we need to calculate the transfer function. Here C of S divided by transfer function C of S by R of S. We need to calculate this one, right? So for that, here C of S is output, R of S is the input. Here also C of S term is there. Just come to I am going to shift this term here, C of S minus, here place is minus C of S, H of S into G of S, right? Here equals to R of S into G of S. Transfer function C of S, here just C of S just common, 1 minus H of S into G of S equals to R of S into G of S. Same process. Here input signal is R of S and output signal is C of S. The transfer function C of S by R of S equals to what? Just here observe. Here G of S, R of S is come to here, and C of this term is moved to here. So C of S divided by R of S equals to G of S divided by 1. Here minus G of S into H of S. This is the transfer function. By eliminate the positive feedback, we get this transfer function. These are the important rules to use, reduce the block diagram, and finally calculate the transfer function of that block diagram, which are very useful to calculate the transfer function by reducing all the blocks into the single block. In that final block consists as the transfer function of that system. This is about the block diagram representation, block diagram rules which are used to reduce the block diagram and finally calculate the transfer function of the given block diagram. For that we are going to calculate the transfer function. This is about the or basic rules or else important rules of the block diagram reduction rules or else block diagram algebra. The first rule is what? Combine the series blocks. And second one is parallel blocks. Combine the parallel blocks. And add means adding. Next, coming to third one is what? Take a point is moving the take a point after the block. Before the block is one rule, and summing point after the block and before the block in another two rules. Here just in for the sixth rule onwards in this today lecture, seventh rule onwards, interchanging the summing point. Two summing points are available. Now I am going to interchange two summing points into the same result. Also combine the summing point, combined these two summing points into the single summing point. Also same answer will we get. Splitting the summing point, if we have more than two number of inputs are available for the any summing point, the summing point again divided into the two, splitting into the two summing points are divided into the two summing points. Also we get the same output. Also this is also one of the rule. And eliminate the negative feedback loop. We are going to eliminate that negative feedback. Finally we get the transfer function that is representing in the block diagram. This is the transfer function of negative feedback transfer function. Loop gain g of s divided by 1 plus g of s into h of s. For negative positive feedback, just in simple, in place of positive we should write the 1 minus. Both are the same transfer functions for the positive and negative feedback loops. These are about the basic rules or important rules are used to reduce the block diagram and calculate the transfer function of the block diagram. I hope you understood everything. Until then, we will see the later next topic. For the based on the rules, we are going to solve some problems, some of the block diagrams. From that block diagrams, we are going to calculate the transfer functions. Later, we will going to discuss for the coming classes. Right? Thank you all.